everybody. I'd like to welcome you on behalf of the Business Change Specialist Group, and so you're here as the chair of this, and also on behalf of the Quality Specialist Group, Margaret Ross, I'm the vice chair. We've got a fantastic evening in front of us. We have Tom Guild, who is an honorary FBCS, and there are very few of them. There is, since the BCS has been in existence, there is only something like 170 in 70 plus years. So it's a fantastic pleasure to have Tom as an honorary FBCS. I think some of you already know him, and I don't think you want to, I think it'd be interesting for you to then carry on. I put in the chat that asking people to actually put your questions in the chat, because we're recording, so we have no disturbance during Tom's recording, but then he'll take questions at the end. And it would be nice if you could actually put into the chat where you are geographically. I put mine in, and especially with Tom, he is, as probably he would tell you, presenting this from Norway. So at that stage, Tom, thank you very much, and over to you.
Thank you, Margaret. And so here, and do we have a third sponsor there? Just the two groups? Okay.
We've
Anyway.
Also got, this is also joined with Hampshire branch and a couple of other branches as well.
Right,
Thank
okay,
you.
well, welcome to all the branches. Anyway, so first slide. Now you might want to take a photograph or a QR of this slide. I will repeat this on the last slide, but it gives you a copy of the slides in PDF format. And you might want to do that because there are a lot of details and small free download references in the slides. So you are hereby warned. We will, BCS will also make the set of slides available after the event if you completely don't get them this time around. So I'm going to try to get through the slides. That is, I am going to stop at the end of 1 hour, and we can then entertain questions maybe for half an hour or something like that. So, but you can put your questions in the chat. The proper title of this is Advanced Systems Engineering or Software Engineering, Quality Control and Quality Assurance. It started life as a talk that was requested from the Swiss Systems Engineering Association for a conference this fall. And they wanted me to talk about the V model, which is very important for systems engineering people, maybe not so much other like BCS IT people, but they wanted me to talk about changes from the V model tradition. So I will start off with that. By the way, my Twitter account and let's see, that's all we have there. So that's good enough. I thought, yeah, there's the email and the website. So any questions afterwards, you're very welcome to email me directly at tom@guild.com and request any additional information you want. Quite very happy to hear from you too. Okay, so here is your typical V model, and the point is the V model is essentially a waterfall model which runs through the design and requirements, and then testing and integration, and out comes the product. Okay, but still in some environments like military projects, etc., these may still dominate as a way of thinking and a way of doing. And the question is, what happens when we enter into agile? Mute. Okay. Again, United States Department of Transportation, in other words, a government department that hasn't quite gone agile. I'm guessing that most of you are already working in some kind of an agile mode, however primitive and however much I might disagree with the type of agile you're using. Now, when we shift from the V model, we're talking about the following things. First, that agile is our assumption, and we are trying to deliver small increments of value and get feedback on them and learn from it, and change our requirements and change our design as a result of that feedback. We're going to do a lot of quality control at the specification level, meaning here, if you like, when doing requirements and design, and we're going to discover defects early. We're not going to rely on a series of tests to discover bugs and problems, which would, by definition and knowledge, cost 10 or 100 times more than if we find them immediately when writing the requirement or the design. We're going to be very interested in methods for preventing defects from first entering the contracts, the designs, the requirements, any kind of specification and plan. And this would be part of what we call quality assurance. When we detect defects at any level, we call it quality control. But when we somehow magically prevent the defects from ever happening at all, we call that part of the quality assurance. We're assuring that we have quality and no defects are entered. Another assumption I'm making is that the specification languages we use for requirements and design are not your, let's call them user story level. They are highly intelligible, quantified, and digital. Okay, so new world for way beyond the kind of things that you find a typical picture is in user stories and that kind of thing. We're not going to be able to totally eliminate testing, however nice that would be, but we can reduce the volume of it, and we can reduce the cost of finding defects in the test when we could have found them earlier at 10 to 100 times cheaper repair cost. And bottom line, what we're looking for is faster delivery of results or values, fewer defects in total for any customer environment, and early delivery of value. So next slide. So basically, we now have, we can emphasize the left-hand side of the V. An ounce of prevention is worth a pound of cure. So here's where you get your pound of cure, and here's where you get your ounce of prevention. And we're also assuming that we're doing agile cycles down throughout the whole thing here. I'm also assuming we have a very strong emphasis on brilliant architecture, something that most versions of agile totally fail to mention, except the humongous ones that have everything, like SAFe. But it's amazing how design and architecture sort of disappeared when primitive early forms of agile, such as Scrum, came onto the scene. I'm also assuming we have a stream of values. That means things like better security, better performance, better user friendliness, qualities and performance characteristics. We certainly are not going to spend a year or two or three before our first deliveries. In my world, even on large projects, we spend a week doing initial planning, and then the second week and every week thereafter is an agile cycle of value delivery. That's what I call my EVO method. And we assume that every EVO cycle, evolutionary cycle, gives us practical feedback, like reaction from people and measurement of how well it went and what it cost, and the opportunity to change things as we go along. Here's just yet another view of the same the V cycle as it was, but we're going to change the emphasis to the left-hand side and invest a lot more in quality assurance. We're not going to eliminate testing, we're going to reduce it. We're going to reduce the cost of corrections. And this reduction is order of magnitude 10 to 1. For example, one of my British clients measured on a very large scale 9.3 to 1. That's published in my book, Software Inspection with Dorothy Graham. Here's an interesting fellow, if you haven't met him yet, Steve Blank. At steveblank.com, you can sign up for his free weekly newsletter, which is one of the few newsletters that I have extreme respect for and expect to find mind-blowing, interesting, advanced things all the time. He largely is working for the US Department of Defense and Stanford, and he's very, very interested in, let's call it very, very, very advanced agile on a very, very large scale. So, but here is a long story short, a summary of how things are today, say in the US military and government area, today's legacy systems, and the very large number of changes or pivots we need to make compared to how they're doing before. There's a some slides in detail there, but very high respect to Steve Blank. It doesn't cost you much to sample his website and see what he's got there. If you're interested in very large scale, very advanced, i.e. like government projects or very large corporate projects, this is systems engineering, and this is not about programming or simple small systems. Okay. Here's another fellow who's into have high respect for. Let's see, where's his, got so many windows over the windows. But anyway, fellows has been working at CMMI, the Systems Software Engineering Institute, but he has done his doctoral thesis, and he's focused on all the things you need to do at the early stages. Here's a list of them, and so I recommend his ideas, and he talks a lot about stakeholder things here. And I've just recently, last summer, written a new book on stakeholders, which you can have a free copy of down there. So next, another one. Here's Brian Gallagher, another advanced thinker. There's his website, and I just want to introduce these people and access to their literature if you're interested in not just what I think about where we have to go and how advanced we have to be, but these people and I largely agree what we have to do to handle the future large-scale complex systems. Okay. Let's see. Where is this? Is the Department of Defense, software agility. I don't really want to say anything more about that. Now we move into my methods, which are characterized by the definition of my methods in the competitive engineering book. Here's a free copy of it. Okay, that generous. Otherwise, you can pay £64 or something to get a paper copy, and you can still get paper copies of it. But we'll call my methods Planguage for planning language. Okay, and they're basically all defined there. And this is both software engineering and systems engineering. In other words, I assume most of you are very interested in IT and software listening to this talk, but if some of you were didn't have much software and were very interested in hardware and other things, you could still use these methods to think about your problems. Okay. I also, at the end of last year, decided to help a friend of mine refocus from traditional agile to something better. This friend of mine, who's mentioned in the book is dedicated to the Success Book, which you can get a free copy of there, tinyurl.com, Success Guild. He spent a lot of his time fighting various versions of agile that he thought were not good enough, a lot of time and energy for a couple decades. And I basically said to him, why don't you give up? The agile is all these religions, and people are religiously or otherwise attached to it. There's not much point in talking to them. They won't listen seriously. Let's ask a simple question. What does everybody who's interested in agile agree about. And he said, well, what? And I said, well, they agree that they want more successful systems. They want to succeed in their projects and they don't want to fail. So I said, well, if we change our focus to that, we might get them to come along and start thinking of what they're doing and their methods, their agile methods and other methods in terms of success and failure. And so just for fun, as is my wont, I wrote a little booklet in October called Success, quite simply. And I define success as reaching multiple objectives for performance and stakeholder value. In other words, reaching the security goals, reaching the usability goals, reaching the performance goals. And I also define failure as not getting below a certain level. We call it the tolerable level, which in fact formally defines failure. So in other words, we use multiple numeric objectives as our definitions of success and failure. And we focus completely on that. And we say, you can do anything you want, agile or not agile, or any version of agile or anything else. And you should be constantly looking for whatever gives you success faster and cheaper. And that's it. So in a sense, we're methods agnostic, but we are focused on success. I've done some work with a group called Essence with Ivar Jakobsen, where he's trying to put together everybody's methods. Scrum is already there. My methods are already there. And we're giving away our methods. We're saying anybody can pick these methods for free and put together sets of methods that work for them. So that's where this ideal is, that you don't just buy into this version of Scrum or that version of Agile. You buy into the idea of picking methods from anywhere where you can get them. And if they work well for you, keep them. And if they don't, throw them away and mix and match so you get the methods you need for your projects or your set of projects. So let me therefore introduce the idea that maybe we should all drop our various religions and adopt, let me call it a higher level of religion, the success in our projects religion. If you're in any doubt why this is important, look up IT failure rates on internet, and you'll find some scary high numbers, which are almost so large you can hardly believe we've been doing this with Agile for 20 years. Okay, time to listen to Einstein's famous saying that if you keep on doing the same thing over and over again and expect a different result, you will be surprised and you will not get a different result. Okay. Okay, so success, right? Not too long ago, I was asked by an American group to write something on very, very advanced Agile, and here it is. And if you go to the Tiny CC Manageability slides, you can get it all. But if you like, I've written up my idea of how Agile really should be. And by the way, it has not changed since I published it in my software metrics book, 1976. But it takes a while for the rest of the world to catch up, doesn't it? Okay. But I'll go. Some of these will be handled in the rest of this talk, but they are essentially what's in the competitive engineering book, and they are detailed in the manageability slides down there. Okay, here's sort of a summary of them. We're very, very value focused. Now, value means stakeholder value. It means any critical stakeholder, if they want something and they value it, and they will pay you for it, or they will refuse to pay you if you don't give it, that's an interesting stakeholder value. And I believe that we need to be far more focused on stakeholder values, and we are not. We don't even define them quantitatively. We speak about value streams all the time these days, but I take a look and we're not really speaking of a stream of quantified value. We're speaking of little processes that are supposed to give some value kind of vaguely. So my value stream is a stream of stakeholder values which are measurable and which are delivered to our stakeholders. And that's the whole point. And other notions here are that we need to find strategies, which, by the way, are sometimes called architectures, or the means to deliver the value. So we need basically a much better and more engineering-like design or strategic planning, okay? And we need to deal with multiple values simultaneously. Our quality control needs to be quantified, not just read through it and say, it's okay with me, I've got no objections. And yeah, so long story short, the manageability amounts to these basic ideas. And there's the manageability slides if you want more detail on that. So looking at the timing, not bad, not bad. Okay, 20 minutes into the hour and got through half of the slides. Okay, now from the manageability lecture, I've had 10 principles, and those of you who know me well know that I like to summarize everything in exactly 10 principles, and I'm still doing that. I'm writing a new book on decision making, and I've got the 10 decision making principles. And if anybody writes me and says, share the decision-making book with me, be pleased to do it. Anyway, manageability principle number 10, you need digital planning instruments to keep track of all these things you've got to do. Now, here's an example of an instrument. It's essentially a spreadsheet, and you can do this, and we've been doing this spreadsheet. This happens to be in an app. Don't worry about it. Now here, again, normally we have order of magnitude 10 critical values simultaneously. Now I've only got 4 here just to fit it on the slide. Okay, but that's the only reason I've only got 4 here. But normally we say about 10, and then we start decomposing, breaking it down, and we never have 35 values simultaneously. These values are quantified. We want to go from 0 to 100%, and for example, from 0 to a tolerable level, 120%. And we have defined scales of measures, so we know exactly what these numbers mean, okay? It isn't done here yet, we're early stage. We also have a set, I only have of resources, i.e. time, people, money, budgets, deadlines, and costs of all kinds. And normally we have about 5 or more of them down here on the table, but I just have one symbolically. So here we have, and here we have different strategies, okay, and by name. And here we have a rating of the strategy. This strategy, new legislation, we estimate, rightly or wrongly, it gives us 70% of what we need to reach the goal. This second strategy gives us, if you like, another 50%. That's good. Maybe we'll make it. These, we don't know what these do here because we haven't even defined some critical goals. So it's time to define these and find out if we have some nasty side effects or good positive effects. Okay. And this one will cost 10% of this budget, and this strategy will cost 30%. And we even compute a value to cost ratio. In other words, the efficiency of it. Now, this is, I give you just, this is my impact estimation table. And you'll find this written up in the competitive engineering book and everywhere else. I just wrote a new book this year called Value Impact Estimation, VIE. And you can have a free copy of that if you ask. Hopefully we have a link later. But I give this, I'm not trying to explain all this because on the BCS courses we've held for many years, we spend at least one whole day explaining just how to quantify these values. And then we spend another whole day explaining how to do this table. So that's 2 days worth of training. And I've thrown, some of you have never seen anything like it before, and I've thrown it at you all at once. But again, you'll have to read the books or go on our courses or something like that. But I give you this as an example of what you have to do for large-scale critical projects, government projects such as the National Health Service or something like that. You can't just use nice sounding words and yellow stickies. That is for children doing small, trivial projects. And if I've insulted anybody, fine. about time. Okay, so summary, what we need is much clearer communication. Of course, I've written a book about that too. If you're poor, I'll give you a free copy. If you're not poor, you can consider going to the store and getting a copy. But and if you think about it, the fact that we quantify all the goals and all the costs, and we quantify the goodness of all the strategies, indicates we're trying to communicate clearly about a complex environment, such as the National Health Service, and a complex set of strategies for making it run better. Okay, and we're doing something I call engineering, okay, as opposed to poetry. I think most of you that I know are with your Scrum-like models are in a mode of what I would call software poetry rather than software engineering. And I love poetry in its place, but not for managing the National Health Service. Yep. Now, here's another example. This is from one of my favorite clients, Intel. And over 20 years ago, they adopted all of the methods in the competitive engineering book. One of their people wrote a foreword to that book, Eric Simmons. And one of his colleagues, John Terzakis, did some research on the side of using my methods. And here's the research, and here's the link to it in detail. Now, what they're doing is they've adopted the planning language with quantified goals and things like that for all of the critical qualities of most all of their Intel products. 20,000 engineers have been trained on a 2-day course to learn to quantify the goals. Okay. Then they apply another method called specification quality control, SpecQC, which is in the competitive engineering book. And let me just tell the story of what's happening here. A team doing requirements for a chip submits 31 pages, right? And what they're looking for when they're doing their quality control is pretty simple. It is things that are not intelligible to other engineers, like the ones who are going to do the architecture for the chip. In other words, ambiguous, unclear wording and things like that. And they find in 31 pages, 312 rule violations of their standard that says it must be perfectly clear to who is ever going to read it. That is 10 defects per page. Now, a lot of people I know would have 100 defects per page or more. We've actually measured over 700 defects per page. By the way, the page here is 600 words. But at Intel, they have much higher standards because of the nature of their chips being sent all over the world with logic in them. It's, if you like, it's hardened software. And they have figured out that they have to be 50 times better, no more than 0.2 defects per 600 words. So what they do is after the first quality control, they say, sorry, no exit. You cannot exit this document to our architect. You have to meet our standards, start reading the rules. So they do, and they actually get twice as good, but not good enough. Then they try again, not good enough, not good enough. Much better, 1.18, but not good enough. That's still 5 times higher than what pays off. By the way, it doesn't pay off to be perfect because then the cost is infinite. Anyway, on this iteration here, they submit 45 pages of requirements and they find 10 defects. That's not bad. That's 45 times 600 words, only 10 defects. That's superhuman. And this is 0.22 defects per page and said, right, you've met our standard. We'll tackle those defects in the tests. See, testing still comes in, but in this case, it is 50% less bug finding in test and repair at very high cost in the test and delay of getting the product out if you do this first. So this is using my methods for specification and using my methods for specification quality control, the combination. And what they do is they get a very early reduction in defects submitted going on further, you know, from, for example, requirements to the architect. Okay, So here's some, again, this is evidence that the methods I'm suggesting work big time, and it is proven and measured and published. What I get tired of is people holding talks on the internet, and I ask the guild question at the end, do you have any case studies or numbers or evidence of how it works? And only 2 days ago, I got the answer, no, we don't. That would be interesting. That was an agile lecture. So I don't trust people who have never measured or even got one case study of how good their methods are. Why don't you ask that question next time somebody holds a lecture? Okay. Here's another example of using the same method, this time at McDonnell Douglas, now Boeing, where we're using it on engineering drawings. And again, same things happens. We start off with far too many defects, but we drive it down by refusing to accept second-rate quality until we get to a quality level we like, and we then accept the quality. So that's another case study with a very good data collection. Okay, so why am I suggesting the Planguage methods? Well, I don't know of any better methods. And if you do, you should tell me, and you should give your numbers and your measures. And I very much appreciate knowing better methods. I don't want anything less than the best methods for requirements and architecture and quality control. So I'm giving that they're simply the best ones I know. And I've been in this business since 1958. I joined IBM. Okay, I've been all around the world, worked with all the large companies, and nobody is telling me they've actually got some proven better methods. So now of course, I would say that, wouldn't I? But easy way to find out is try them out. So these methods are studied, measured, corporate adopted, publicly reported, and we have decades of stable success. In other words, at Intel, they're adopted over 20 years ago, and they've been going for 20 years with thousands of people. So it's not like they adopted it one year, found it was bad, and then adopted another method. Okay, they keep on going because they themselves have not found any better methods. And there are several other reasons. Another one is that the methods are known to be scale free. In other words, they work on extremely large projects and extremely small ones and everything in between. Here's the documentation for that down here. Here's another very interesting fellow I'd like to introduce you to, Rick Duff. He's the first guy I ever heard talking about agile in the 90s at systems engineering conferences at INCOSE. And there's his website, parshift.com. So I say he always has deep insights on whatever he does. And he's not talking about trivial systems. He's talking about really large systems. So Rick Dove, parshift.com. May I recommend him to you? See, there we go. Now, what do you have to do to be able to use these wonderful methods? Well, it's essentially free. I just gave you a free copy of the detailed handbook on how to do it. So that's fairly cheap. There's the link again if you missed it. Okay, and everything I have is essentially freeware, right? I want to give it to people smart enough to use it. And my pleasure will be getting reports like the ones we get from Intel and Boeing and other corporations saying how well it works. That's my greatest pleasure in life. Okay, and that's why I've been doing free courses for the British Computer Society and Margaret and so here for many years, as some of you know. So you don't need any permission to use the methods. You don't need any certifications. You don't need to pay any license. The best things in life are free. There's a good Frank Sinatra song about that. If you didn't know, look it up. Now, again, what is it that determines whether you're doing it right? And it's very simple. You are getting higher success rates, lower failure rates, higher levels of value delivered early. It's measurable that these methods are working. If you aren't getting measured success, you aren't using these methods. It's that simple, okay? Yeah, enough of that. Okay. So again, here is, in a sense, a list of the various techniques you'll find in total in the various books, competitive engineering, and later books. Okay, one of my favorites that I didn't emphasize enough in competitive engineering is how to decompose into small steps of delivery. It's one of my favorite subjects these days. But I've written much more about that in my earlier books, the booklets the last 5 years. Okay. So we talked about preventing defects from happening. Now, many years ago, IBM came up with a process called Defect Prevention Process, DPP. And IBM never sold it or marketed it. They just used it internally to very good effect. And then it got forgotten. I mean, like, I don't know of any universities that teach it, though they all should. And you know, nobody's selling it to you. It's absolutely free. Here's a diagram from Raytheon, who has a large electronics corporation who uses it. Basically, the defect prevention process, let me say it as simply as I can. There is a constant daily analysis of, let's call them bugs or defects in requirements, with a simple question being asked of everybody: what is the root cause? And what could we do in a simple way, maybe today, to get rid of the root cause and reduce the frequency of these defects or bugs getting entered? And the next is, let's do it. Now, the funny thing is, see this fellow here, you'll hopefully recognize Elon Musk. And I started last fall writing a book I'm still working on called Musk's Methods. There's a free copy of it. And I keep on adding every week some ideas, because he's never written his book on his methods, but he has held lectures on them and has people who've worked with him, like Joe Justice, who's also a very interesting guy and has very interesting books on it, that have told us what his methods are. So I've been able to accumulate about 70 pages of his methods. And I think he's the greatest agile practitioner on the planet. He is a bit extreme. I mean, not everybody has the guts to push as hard as he's pushed, but maybe you don't want $300 billion in your pocket. I don't know. I mean, that's too much money for me, I can tell you. What would I do with it? Okay. But if you take a look at the Musk's Methods book, you'll find that Musk encourages his teams to do this every day, to ask what went wrong, what could we do to improve it? Let's improve it right now on a trial basis, our team now. He's doing this, okay? So if you think this method died out with IBM in the 90s, you're wrong. It's being used with a vengeance by Musk to build incredible products and earn incredible profits. And that should be a good argument for most people. Now, here's the originator of the method, Robert Mays, who published his stuff in the IBM Systems Journal. He also kindly wrote a chapter for us in our software inspection book, okay, and described the method, and I've gotten to know him. And trying to think, is he still alive or not? We're all getting kind of old. But he's the originator of the method, and he won a corporate prize from the chairman of IBM for his good work. Okay, here's the basic method. It's basically a plan, do, study, act cycle of figuring out what went wrong, what are we going to do about it now, let's do it, and let's figure out if it worked. It's that simple. It's like a Deming plan, do, study, act cycle. Here's a report from Raytheon over a many-year period where they're using the defect prevention process, and they're using this inspection process. By the way, description of the quality control inspection plus the defect prevention is in this book, which I believe is still on sale, and I don't have a digital edition to give you. But it's in there. Anyway, they start off observing that they have 43% rework effort. In other words, they're spending 43% of all project time. They have 2,000 software engineers, by the way. 860 of those engineers have a full-time job fixing bugs, which they themselves put in. It's like an army that is friendly fire and shoots a lot of their own people. And so most of them have to help save the people they've shot, and they can't actually fight the war. That would be a very ineffective army. Anyway, they start using these methods, and within 1 year, they get a reduction to about 27%. And then by persistently learning, why do the defects occur? Here, they put in some top manager's good idea that didn't work out, and they rejected it. They get to actually be 10 times better at rework. In other words, the rework percentage is, in fact, a few years after this, we have the data, it's down to 3 or 4%. You, right now, have something like this if you've not been managing this for several years, okay? Try measuring the amount of time and effort used to fight bugs, sometimes called technical debt, sometimes called testing and retesting, all kinds of things. So in fact, it's so pervasive that we think it is normal. It is not. It's an aberration, okay? Here's some of the results from Robert Mays's and other parts of IBM, where it took about 1 year to reduce the defects they had to deal with in test by 50%, and then another year by 70%. And then another part of IBM in Minnesota reported, this is Steve Kahn, who's still alive and well and appears at meetups recently. They got to something like 99.9% of the defects prevented. That's very advanced compared to over half of them not prevented. So there's tremendous potential in this corporate learning defect prevention model, where you delegate the power to the people, to the software and systems engineers, to figure out what is wrong with their own process. I remind you exactly what Musk does, okay? Here's another fellow, a lot of time for, Capers Jones, and there's his website with masses of really good free stuff on testing and defects and inspections and everything. And here's the long list of all the techniques you don't really know about or do, except maybe a few of them. So maybe you'd like to add to the list of defect removal methods or quality control methods, okay? Here's another basic idea that IBM certainly was very good at doing, and that is that you take note at which stage of the processes your defects are occurring and try to detect them in that stage, or at least shortly thereafter. Don't have requirements problems that are found in final systems testing 3 years later or something like that. That's silly. So long story short, you have to have some idea of where are our defects happening. We know it's all over the place on the web, what's wrong with software engineering, and number one problem always comes up is bad requirements, okay? And yet these defects are showing up as bugs in customer software, okay? And then after that comes design. So there's a slightly larger Musk's methods thing. There's a wonderful, if you got time, watch him talking away about space and his methods. And that's the beginning of my book there. He in that video, he lays out 5, really 6 methods. And one is kind of fun. He says, basically it says, assume all requirements are wrong, no matter who wrote them. In other words, no matter if even Elon Musk wrote them. Very interesting. And he then says basically the same thing about designs, snuck in here, all designs are wrong, right? And then he talks about deleting superfluous parts of the process, maybe a little bit too much at first. simplification and optimization. By the way, he says these things need to be done in sequence, and he didn't always do them in sequence, and he bitterly regrets not having always done them in sequence, right? Here's the thing he's most fanatic about is the speed of the cycle time, the acceleration of doing things. So he, for example, changes his actual production models of his cars at least 20 times a week. And other car manufacturers do it once every several years. So he's radically different in this respect, but that enables him to constantly improve the vehicle. I drive proudly a Tesla 3, and it's an amazing vehicle. Okay, and then the final step is automation. Again, he loves automation, but he bitterly regretted too much automation in the Tesla 3 production line. History about that. And here's another, his last remark isn't really point 6, but it could be. And he basically says everyone should be a systems engineer, understanding the system at a high level and avoiding bad optimization because you only think about coding or use cases or something like that. And you don't think about your stakeholders and their values and their constraints and things like that. Anyway, that's the beginning of me writing the book was. And so the first 3 or 4 pages are on this, which I've reinterpreted. But then I found by reading books and listening to videos, I could pick up a lot more of his engineering philosophy. And I think we can't all be Musk, but we can all try to be a little bit more Musk-like. Okay. One thing little known, everybody's heard of a Tesla and Musk, but did you know that among many other things, the 3 safest cars in the world are Model 3, Model S, and Model X of Tesla. And here are all the other cars in the last 10 years which are not as safe. Now, that's interesting. Most people don't even know that that's true. These are independently audited by some kind of a, it says so, in National Highway Traffic and Safety Association or something like that. Now, the reason they are so safe is that Musk has decided that one of his values is to have the safest cars in the world by far, to reduce the deaths, okay? And he's recruited first-class safety architects and said, go bananas, don't just follow the safety regulations, go further than them, make cars safer than any competitor. And they've really done it. And they've done this on a large number of other values and qualities, but this is so very nice and numeric and so unknown, okay? So thought it's worth pointing out. Makes me feel safer running around in his car. Here's some more Musk about using first principles. And I think I don't have time to go into this in detail. I should probably use an hour on it, but there's a very nice video on it and the summary of it from one of the books I've read called Power Play that you might enjoy. But first principles, in other words, basic thinking, challenging conventional thinking and conventional ideas and saying, what is really the smartest thing to do, no matter what the other car manufacturers think. Imagine this guy's audacity to go into the car manufacturing business and beat everybody else on almost every parameter you can imagine. So they're all trying to catch up with Musk. That's what happens when you use first principles. You become number 1 in the world. And if you are employed by somebody or corporation, or you're doing a startup that wants to become number 1 in the world, take a look at the first principles ideas. Okay. So I'm not sure why this is in here, except I like it. I was reading a book about Amazon and Bezos, and I came across a point in their life where they're reading Edward Tufte. Some of you will know him as a master of visualization. And they decided to get rid of PowerPoint presentations entirely at management decision-making and require a 6-page maximum text, which everybody in the meeting spent 20 minutes reading with no talking, no presentation. And then they went into deep sentence analysis. This is very close to my specification quality control at Intel that I showed you, right? And I've written a little book on that called Planalysis, right? Free copy right there. And a little bit of fun with Stalin and the Russians here. Anyway, something to think about next time you see a PowerPoint presentation. Here's an example of somebody very successful in business, almost as successful as Musk, and he's totally deleted PowerPoint and believes in writing it down and letting people read it. This is analyzing each sentence deeply. Okay, so I hope that threw an awful lot of ideas at you. Not you can forget all of my ideas. You just do everybody else's ideas. You'll have a lot of really good ideas, but would be nice if somebody thought they wanted to play with my ideas. So the slides copy is there. I think I made it even easier to get the slide copy with a QR again. And basically, I'm done with the lecture, and 8 minutes left of the hour. That's not bad. And by the way, at the end of the lecture slides, I have a lot of detailed literature references, very many free books and papers on these subjects for those who want to go deeper. So with that, I will stop the lecture.